Before starting the actual project, I've gone back to the start screen. I'm switching to gesture mode for my mouse movements and the workbench to part design. The little project which we're gonna work on is a Y-axis holder. This allows me to replace the Y-axis fixture of an old printer that is using simple plastic bushings. That allows me to use Eiger RJ4JP bearings, which are well known for good and smooth movements on the steel axis of 3D printers. That is the fixture I'm going to create. It's not too complicated, but still gives us the possibilities to have a look at several things you need to know as a beginner. So the first thing is we switch to the workbench. That is part design in this case. I'm mostly working in part design workbench because that is the most important workbench nowadays in FreeCAD for creating mechanical models. In the part design workbench we have to know a couple of things. First is here we have the combo view. The combo view has two windows. One is the model window, one is the tasks window. Later on you're gonna see what's in both of these windows. In the moment everything is gray here in the part design workbench, and it may also be that your layout is a little bit different, so you can easily move these toolbars to where you like to have them and then have a similar layout as I have. Let's first start a new document. Create a new empty document. Once we started it, it activates the 3D screen. In the 3D screen we've got the navigation widget, which we're gonna look at later when we have something to look at. In the moment we don't have something. So the next step is when we switch to the tasks window, it shows us create body, which is the obvious next thing to do. Once we created a body, we need to create a sketch. We could also start with using a predefined object like a cylinder, a sphere, a cone or something like that, but that is not too usual to start this way, and it's also not the way that I'm usually doing it. I prefer to work with sketches. A sketch is a two-dimensional drawing which then will be extended in one or the other direction and later on may also be subtracted from an existing object in one or more dimensions. And this 2D drawing resides on a plane. We have three base planes. We've got the XY plane. That is the most important plane because that's the plane most of the constructions are based on. It's like you're sitting in front of your work desk and you put something on the desk and you look to it from the bird's eye view, or if you put it on your drill press and you drill from the bird's eye view. So that's how you would look at this object if it resides on the XY plane. If you draw an object where you look from the front, larger object, front side of a house or something, then you would look at the XZ plane, or if it's from the side view, then you would look to it from the YZ plane. In many designs later on you will use different planes Mostly you will use the XY plane as the starting point. Click OK, and now we have an empty drawing screen. Here, left side, we have a couple of things in the task window. We have the toolbars, and we have again the 3D widget. We have two axes, horizontal and vertical axis, and here we've got a construction helping point. This point in your FreeCAD maybe is much smaller. I show you how to change that. If you go to Edit Preferences and you go to Display, you will find the so-called marker that I've changed to 13 pixels. It might be 5, 7 or 9 pixels in your case, so change it to a little bit bigger size. And while you're in, go to the Colors tab for the Sketcher. So first you click on Sketcher on the left side and you click to Colors, and there you find the vertex color, which in your case is a bright red. Change that to a little bit darker red, because then you can see changes easier. You will see this in a few moments while we're working. So that is all we change in the settings at the moment. Click OK. Good. So before we talk about this and that things, let's just start to draw something. My design is based on a block, and so let us just draw a block in on an arbitrary position. Doesn't matter where. Don't start at the center point and don't start at one of these axes in the moment. You can drag it around on your likings, and FreeCAD part design is a so-called constrained parametrical design. What does that mean? Constrained is, if you say, and FreeCAD did it for us, this line is horizontal, this line is vertical. Another constraint would be that we say this line has a defined length. So here in our constraint toolbar we have a length constraint for a horizontal distance, and the horizontal distance for this line is going to be 32 millimeters. If you hear it clicking, that's the original part I'm sometimes taking into my hands. Now we have a new constraint. On the left side there's a window. If it's closed, you can open it, that talks about constraints, and here you see that is constraint number 9, 32 millimeters. We leave it as it is, we don't give it a name yet. That's something that comes later. We also have a vertical length, and if I look, I would create this with 50 millimeters. 50 millimeters. So now it's a little bit bigger than our screen. That brings us to the point where we have a look at this little toolbar up there with the blue icons that gives us some view possibilities. This one fits the whole content onto the screen. If we want to see it from a three-dimensional perspective, we can switch to the axonometric view, but this won't be good for creating things in the sketcher. Maybe later on when you are convenient with it, then it may make some sense. In the moment you better look at the bird's eye view, and that is the top view, which also is represented by a number. We have 2, 3, 4, you can see the numbers on the left of the help text. And sometimes when you key in numbers, you will see your views switching. That is because you forgot to activate your input field, which happens to me also. Don't blame yourself. It's not needed. That happens to everybody working with FreeCAD. And you now key in a number like 1, 2, 3, 4. You will change your view. So don't be shocked. Now, usually you will fix your first piece or the first part of your construction to a point in the 3D space, and that is the origin point. And now when we move the mouse to the origin point or to another vertex extension point, you can see it switches to yellow, and that is why we change from a bright red like we have here for the constraint numbers. If you don't change it, it's not as easy as here to see when it's going to be activated. Okay, so let us fix this rectangle somehow to that origin point. Well, you could take the easiest way, and that would be you activate both points, one of the corner vertices and the origin point, and then you use the easiest coincident constraint, which is point on point. Well, that would be one possibility, but usually these drawings are centered to the center of gravity, and that is where lines between the vertices would meet. And we can do this by telling these 2 points and the last point, and select this one as the last point, not as the first or second point, always as the last point. These first 2 points are symmetric to the last point. So that creates a symmetry constraint, which you can see with the little arrows pointing in the diagonal direction towards the center point. And now, as you can see, our construction changed color from white to green, which means now the sketch is fully constrained. That means the solver does now know where it is exactly in 3D space. And what we're going to do is we're going to close this. Again, use the functionality to fit the content, and use one of the possible tasks. You can also select these things here in the toolbar. If you switch to the model tree, you don't have the tasks visible. You can switch here and select what you want, which in our case is we want to create a pad. A pad is a 3-dimensional extension to the sketch we have created. And again, we need the size of this object, and this is going to be again 32 millimeters. So now we can look at our 3-dimensional object. Many of the tutorials, also the tutorials you can find in the wiki, would now tell you a wrong way of designing. And that would be, they would say, okay, now the first thing is we need a hole, and we click to this face, and then we create a sketch on this face, and blah blah blah. This is not correct. And we also will remove this pad again. We just delete the pad. Don't delete the sketch. You can't delete it as long as the pad is existing. So we create this one, and we switch the sketches on and off. There's a second sketch now created automatically. That's what we can delete. We still have our basic sketch. And what we're going to do is we're going to rename that sketch by clicking the F2 button. You can also click and choose the context menu and take rename and name this one master. Why? You will see a little bit later. We go back into the sketch by double clicking it, and now we're gonna do the following. We will put in another line. This line, as you may have seen, and I'm repeating this, I delete it. Look at how I'm creating the line. I'm moving it from top towards bottom, and when it comes close to be vertical, it will show us a little line below the coordinates, and this line is vertical. When we now fix it, it will automatically change to be constrained vertically. That is something that is called an automatic constraint. Sometimes it's hinderly. Then you would be able to switch off the auto constraints in this Edit Controls tab. We leave it as it is. In a moment it's no problem. Be sure when you use auto constraints to also activate avoid redundant auto constraints. Not needed to know what that means, just keep both active or auto constraints off. Now the next thing is we give this an extension. We say vertical distance 32 millimeters. And in addition, we give it a name, and we call this height of block. So we have a width of 32 millimeters. We have a length of 50 millimeters and a height of 32 millimeters. And now we close the sketch again. We may leave it under constraint because we are not going to create a so-called feature, a three-dimensional extension of our solid from this sketch. This sketch will only serve us values and ideas for our further design. So we're going to extend this master sketch furthermore while we're constructing. But first is, now we're going to create a new sketch. Be sure you have not selected this master. Be sure you have selected the proper body, which if you only have one is automatically done, but later you may have more bodies, and always be sure you work in the right body, which is visible by the bluish underlay of this text. Good. So we create a new sketch. We put the sketch on the same plane, and now we still can see our previous master sketch. If you don't want to see it in some case, which doesn't make sense in the moment, but you could switch it on off by using the space bar. So we have it visible. And Now we can use the carbon copy, which means we copy the geometry from another sketch to our working sketch. We click this and we select something from that sketch, and that copies us everything, and it also includes, this time in a orange color, the constraints that were defined in the master sketch. This piece we don't need, so we can delete it. You can't delete this one because that's only the visual representation of this line in the master sketch. Now, as it took over the constraints, it's automatically also fully constrained, and we can close it. So now we're gonna create our pad again. Be sure we select the sketch, we create the pad, and in this case we don't select or we don't type a length. What we're gonna do is we're gonna key the equal sign, and this brings us to a mode where we can retrieve parameters from other sketches or other parts of our construction. If we want to have values from our master sketch, in this fact the length of the line, we key in M for master sketch, we select this with the mouse, and now we key in C as for constraint, and this brings us a list of the defined constraints in this master sketch, which obviously is just one. And if we now click OK, this will extend our block exactly to the defined length. And we can now go and say, we go into the master sketch again, and just let's change this to 50 millimeters. We close, and magically it changed the block height. So let's go back and change to the proper 32 millimeters as it was previously designed. So now we have our basic block. The block itself is somehow mounted to the other parts of the support in this 3D printer, and the main function of this connection is a pair of rectangular cubes which we will create on this side. Now this side, as we know and as we can see if we switch the origins visible using the spacebar, is also on the XY plane. Now let's create a new sketch on the XY plane. As we're gonna construct below our previously defined block, we go into the model tree, we click that block and use the spacebar to switch it invisible. We keep the master sketch as it was. We now need the position of one of the side lines, and that's what we're gonna get using so-called external geometry. We do this by clicking the symbol for the external geometry. This brings up this little wireframe cube at the cursor, and we select one of the lines that is enough for what we need. Now the next thing is we need some helping construction to find out the proper positions for our blocks that will be constructed, and therefore we need a new mode, and this mode is switched here. Any line that is constructed while the mode is in this black-white lining version will be exposed to features and exposed to the remaining construction. If we switch to the construction line mode, these lines will not be exposed and will not be used for the features themselves. So we can use these lines for internal construction inside a sketch only. Now let's start. We draw a line. We draw it close to vertical, and this line gives the distance from this edge to the rectangular blocks. And this distance is known. I switch on two of those vertices and it's 11 millimeters. Then what I know is I draw a new line and the width of those blocks is going to be 4 millimeters. So we put in a new constraint of 4 millimeters. The blocks are symmetrically and they are 22 millimeters apart from each other. So let's create a rectangle and let's constrain this rectangle by using these 2 points and the horizontal center line and a symmetry constraint to be exactly in the middle. What we need is now we need the length, which I said is 22 millimeters. So this gives us nearly all we need. The next thing is we create another rectangle, and this rectangle is 5 millimeters away from that rectangle, and the same here. This time we're using another possibility. Instead of a symmetry constraint, what we're doing is we name this constraint, we double click and we say that is width of metal, and in this case we select these 2 points, vertical constraint, equal sign, brings us again the dialog for reference constraints, that's what we call it. And now all we need to do is, because it's a constraint inside this sketch, we start with typing the C. This brings us to constraints, as again we have only one. It's constraints width of metal. Brings us to 5 millimeters in grayish text, and the 5 millimeters constraint now in orange, which means this is a constraint that is referenced from something else. So now this brings us to the definition of the 2 needed rectangles, and we switch to construction mode again and we use real rectangles in white standard line mode. And what we now do is we want to constrain these to fit on these rectangles. How can we do this? Well, one possibility is we use the point on object constraint. And as we have several of them, we first click here before we selected anything. This brings the cursor with the symbol as we see in the toolbar. And now in sequence we click point, object, point, object, point, object, point, object. The same for the lower one, point, object, point, object, point, object, point, object. So this is all we need in this case. Unfortunately, what we have is our sketch is now not really constrained, because there is still 8 degrees of freedom, and in 0.18 we can see where they are. They all have to do with our helping lines. Now, as the helping lines don't really play a role in the feature further on, we do the following. We click the line and we create a block constraint on the selected item. That means the line is blocked. We can do it again in sequence, and we just block all of our construction lines. And now we have a fully constrained sketch. The construction lines do not change color, but our real lines have changed color. We close this and we create a pad. Now the pad should be 10 millimeters, and if we fit everything we can see this doesn't look like 10 millimeters. Actually, we don't see the pad. Why? The problem is we created our sketch on the XY plane and it extends towards the positive Z direction. Z or C direction. So if we verify this, let's make it 100 millimeters, we can see it grows out here. So how do we get it pointing in a different direction? That can be achieved by using reversed. And now the pad points in the opposite direction. We could also, not in this case but in other cases, use symmetric to plane. So this would be 50 millimeters this direction, 50 millimeters that direction. So not what we need, and we don't need 100 millimeters. We also need the width of the metal. So we give it a length of 5 millimeters. Now we have this piece. Before I carry on with the construction, I would now verify if this is correct by doing a test print or something the like, but I'm not going to do this. Actually, I will just carry on constructing, even though it may still be wrong what I'm doing. We need to fix this block to the other part of the fixture. The next thing that I need is the fixing holes to get the whole block connected to the existing fixture. So how I'm going to do this? I will create a new sketch, again XY plane. As we did before, we switch the feature invisible and we activate both the master sketch and the previous sketch, so we have references to what we've created before. Now first is we need the distance of the holes to this side. So let us grab this side as an external geometry be sure we switched to helpline mode, and we create two arbitrary rectangles. And now we want to have these two lines be on the same line as this one. How do we do that? One possibility would be we select the 3 points and we use a coincident constraint. Would work, but I would like to use a more smart mode, and that is we create a vertical constraint on the 3 points. That means it puts the 3 points in one line exactly vertical. Now we need the width of those lines, so one of the holes gotta be 18 millimeters from the right side, and the other one got to be 4 millimeters. Selected something wrong. Gotta be 4 millimeters. So just move the measurements a little bit uncluttered. Again, we can look what our sketch tells us. We still have 4 degrees of freedom. This time we can do it by defining the length of the lines. And as we don't want to see these measurements because they don't really play a role, we can move them to the so-called virtual space. So constrain this one, constrain that one. Now this would be wrong. It told us, let's try it again. This would create a redundant constraint, so we don't want to do this. We select this constraint, we put it in the virtual space, still have 2 degrees of freedom, which are these 2 lines, and they are not yet fixed somewhere in the vertical direction. Well, we can do this by again using a distance and a distance here. And to unclutter it up to the so-called virtual space. If we want to see what's in the virtual space, we can swap between virtual and real space with this icon. So this one is still to be in virtual space. Now what we have is our 2 constraint visible, and the unneeded constraints are invisible. Our sketch is fully constrained, but we don't have the holes as such yet because we didn't know where they have to be in the vertical extent. So as we know these 2 rectangles are symmetrically, all we do is we create one of our holes, we switch to real mode, and we use create a circle in the sketcher by selecting the center point and a point on the circumference. Now first is we define the diameter of this circle, and we have 2 possibilities. One is constrain with radius, constrain with diameter. I want to constrain with a diameter, and it shall be a 4 0.2 millimeters diameter for inserting a 4 millimeters bolt later on. I take a little bit more because usually the 3D printer will create those holes a little bit too small due to the restrictions of how holes are created with 3D printers. Now we have that circle, and I have to first get out of the mode for diameter constraining, and I do this using the right mouse click. That always brings us out of such modes that repeatedly do some. For instance, create points, and to get out of here, use the right mouse click. I select these two, and using the delete key, I take them away. So now we have the circle, and the circle gotta be here, and another one gotta be here. So let's create a second circle, and as it's going to be the same type of bolt, what we do is we click both circles, and now we're using the equal constraint, which means the properties of both circles will be equal, and the property in this case is the circumference, so both are the same size. And now we need a line that is exactly going through half of this rectangle and crosses these two lines. Well, how do we get that? Different possibilities. Let's take the easy one. And the easy one is we create helping lines. One goes this way, one goes that way, and one goes this direction. Now let's say this line ends on that line. Let this point also be on that line. Now let's grab with external geometry the rectangle. We select two of the lines. That brings us to 4 endpoints. That's what we need. We don't actually need the lines. What we need are the endpoints. And we use the coincident point constraint. Click 1, 2, 1. Sorry, didn't get it. 2. This one, that one. This one, that one. And as you can see now, if we fix this line to the crossing of these two lines, we're exactly in the middle. Well, create a helping point. Put it somewhere. And now say this point is on that line. It jumps here. We zoom out a little bit and take this point. Oops. Take this point, that line. This point, that line. And now this line is locked and fixed to where it ought to be. And finally, what we need is coincident of points. This point here, this point here. And now we have all that we need. We can close. And now we create a pocket going through the complete block. And again, we don't see that it protrudes in through the block. It goes outward and we don't see it because it creates a hole in free space. Again, we gotta go to reversed, and that puts it inside, and we can just let it be going through all of the block. Through all. So we have the holes in here. Well, how do we get the same holes to that side? That is fairly easy. As we know, our origin is on this plane. We can mirror these two holes to that side. So we select the pocket feature and we create a mirror feature. Now the mirror feature first, as we can see, tries to mirror somewhere else. We have to select the proper axis, which is the horizontal sketch axis. We could also have clicked it after select reference, and that would bring us to the base XZ plane, which actually is the same as the horizontal plane. Good. So now we have the fixing holes. At that point, it's time to save. Because if you save, you can get back to where you were before in case you somehow spoil your construction. By standard definition, FreeCAD will save the last 5 versions of your drawing. Okay, so at this point in time, I want to create a new block that is integrated in the main block, and through this block I want to create the holes where I will later put the IGOS bearings into. So how do I do this? First thing is, now I want to construct more or less on this plane, but not on that face. As I said before, this is the wrong approach. This can later on lead to problems. So what we need is, we want to have a plane which is exactly on this face, and we create this plane by first showing our origin. We select the plane that is parallel to this face, and we click on create a new datum plane. This creates a reference plane which is locked to this original plane, but it gives us the possibilities to move it in space. We can move it in Z direction, and as you can see, it moves with negative set in this direction and with positive in the opposite direction. So we want to have it pointing towards us with positive values. So we have to flip the side. And the value is 25 millimeters, but 25 is not exactly. We better go and do this again with a reference to another sketch. So let's fix it at 25 at the time being. Go into the master sketch again, and that's the 50 millimeters, but this 50 millimeters has no name, so we call this length. We close it, we go to the datum plane, we double click, go into this set value, key the equal sign, M for master, click it, C for constraints, and there we can see it, constraints block length. And we divide this by 2. The result 25 millimeters. So this means in the moment we would choose to make the length different from the 50 millimeters, the plane would move accordingly. So we give that name also, we give the plane a name, sorry, and let's call this front. Good. So you can see this in this yellowish color, and later on this yellowish color will only be disturbing, so let's switch it off visually. We only need to make it visible once we want to know where the hell is it. And we select it, and while it is selected we create a new sketch. Now in this new sketch, what we know is we want to make a hole with a diameter of 15 millimeters. We select diameter constraint 15 millimeters. And we want to make this hole on a position. What I know is that the center is exactly on this outline here, and now we want to fix it to that outline, but in this view we don't yet have any sketch that we can see. But what we can do is we click the alternate key, we hold it, and we move the mouse, and now we can see our existing master sketch coming up. And now we can go and say external geometry. We click this line in the master sketch, and that brings us a reference point into our current drawing. And if we now reset back to the view, we can do this using the gadget here. That's the moment where I can show you how you can operate with this gadget. Zoom to fit, left, all possible view variances can be selected with this little gadget. So what we need is we need a view from the rear. That's where we started. Good. So let's create a helping line. Now we created a white line, so that would be a real line. We want to switch this line to be a help line. That means we select the line and we click the line mode button, and now it is a blue helping line. And the next thing that we know is that the center is in half of the length. So this, let's switch our pocket on, and let's give this line a length, and let's go into master, constraints, height of block divided by 2. This puts it onto the 16mm position, which is exactly in the middle. Fix the rear view again. So the problem is now we first have to create something where this hole can protrude through. So let's simply select the circle and make it another helping geometry. Create a new circle. Start the circle in the center. Don't do this as long as you're not really convenient with your mouse and FreeCAD. Better do it. That was one escape too much. Better do it the classic way, which is create a circle somewhere, select the center points, put them onto each other by coincidence, and now we need a new diameter. And to be flexible, we don't do it the easy way, we do it the complex way. We create 1 point, 2 points. We put this point onto that line. We put the same point onto the circumference. Put this point onto this circumference, as well as on this line. And if we now define the distance to 5mm, we now have a block that is in the right size. We close this, and now what we do is we create a pad, and let us make this pad in a specific way now. We don't use symmetric to plane, and we don't only put it into one direction. What I'm doing is I'm using 2 dimensions. I want to have it 15 in this direction, and I want to have it 65 in the other direction. I could also use the equal sign and add 15 to either side of the 50 to get a complete length of 80mm. That would be possible, but let's leave it as it is. Unclutter the origins again, and now we can select our front datum plane, create the next sketch, and as we've done before, we make the previous sketch visible, we make the feature invisible. We have this circle, we select the circle as external geometry, we create a new circle, and we give this circle a diameter of 15. That makes it fully constrained already. We close, and we create a pocket through all. Again, reversed and symmetric to plane. Why? Well, we start here and we create the hole into this direction through all. But this is the opposite direction. If we don't use symmetric to plane, it won't go through. So that is what we need in this stage of the design. Now there's one thing left over in this little design before I make a test print, and that would be a possibility to lock my two bearings, which are going to be inserted from either side, to lock these bearings somehow in position. And I want to use a hole and a screw for the locking. That is good enough for what I need. So let's switch the origin on again and see if we can meaningfully do this from one of the planes. Yes, we can select the YZ plane in this case. We create a sketch on the YZ plane. First, take an easy approach. Just visually put your circles where they ought to be. Close it. Create a pocket. In this case, we can create a pocket dimension, and we just use a dimension that lets it go into the inner side. Good. So now, as it is approximately correct, time to fix the proper position. Open the sketch again, and what we need is a reference to our previous pocket, and this means now we have to go into a point where we say, how do we create this? We have two choices. We could create datum planes locked to the faces that were created here. We know our 50 millimeters length. We can fix how big the holes are. So to fix the size of the holes, I select both of them. I click on diameter constraint, and it asks me, do you want to share the same diameter for all selected elements? And I say yes, I want to do that. And they shall be 3.4 millimeters, which is a good size to afterwards put a thread into and a little bit of a locking screw. These both are now defined. If we update the drawing, we can see the ghosts are going away that have been created by the feature. Good. So where are they in space? In the moment, if we switch our pocket off, they are just defined arbitrarily, and we need some of our existing sketches again. And in this case, we can take our sketch that created this circle, that is sketch 004. So the problem is, what we don't have in the moment is a reference to the height, to the position, the vertical position of our sketch here. What we know is that it must be in the center of one of those circles, but we don't have a line or something that is derived from here. Even if we go and try external geometry, we get no reference point, we don't get anything. What we now need is a so-called reference line. How do we create this one? We close our sketch, we hide our feature so we can still see the circle that we created in sketch 004, and now we select it and we create a reference, a datum line, and by default it's there where we want it. It goes right perpendicular to the center as the axis of curvature. That's all we need. We close this, go back into our sketch, and voila, we have the line. And this line can be selected as an external geometry, gives us a reference line, and we are able to use object on line once and twice. So now they are centered, and again I'm switching off my pocket, and I know the length here is 80 millimeters, so let's select both, give them a distance of 70 millimeters. So that puts them into a proper position. And there's only one more constraint left over, and that is we need to make both symmetrical to the center. Sorry, I need to switch off the origin. And now it is complete. We should have, there's one more degree of freedom, and that is here. No, it didn't. Sorry, I have to repeat it. Select 1, 2, select the line. Now symmetry is here, and they are switching to green, and they are ready. We close, and we look at our final object, and that is all I need in this stage of the design. So the last thing that I have to do is I'm uncluttering the stuff, switching everything off that I don't need in the moment. Just the final object, and then I select the final object, I switch to a different workbench, I switch to mesh design, I select create mesh from shape, that brings us a dialog. I select standard meshing options, and I have a mesh created. We can select this mesh and we can analyze the mesh. Check solid mesh, it tells us it is a solid, and we can analyze, evaluate and repair mesh and let it analyze, so it says looks good, no problems. Good. So now we click with the right mouse key into the context menu. We select export mesh. Calling it Y holder. Select my new number 1 slicer. There we have it. And I slice it. And it is a valid object. So all I now have to do is put it onto my existing 3D printer and see if it finally works. Thanks for listening, and Hope to see you again in another video. Thanks for listening. Thanks for watching. And if you liked the video, you might give me a little tip. You can see my PayPal address after the video in the comments. Thanks, and look for more of my videos. Bye.